Hey, what's going on, guys? Let's do this problem right here. This question is asking what is the third degree Maclaurin polynomial for f of x is equal to e power 4x. Let's see how we can do this. First of all, if you notice that this is similar to Taylor polynomial. If you know Taylor polynomial, the only difference is we are going to apply 0 for a value, right? In the Taylor polynomial, we have values, but for Maclaurin polynomials, it's going to be 0. Now let's go ahead and find this answer for this one. And since they are talking about third degree, we only consider three derivatives. So this going to expand like this. First we are going to have f of x. So that's going to be f of 0. Everywhere we have f of x, that's going to be f of 0 plus f prime 0 over 1 factorial x power 1 plus f double prime 0 over 2 factorial x square plus f triple prime 0 over 3 factorial x cubed. So this is going to expand like this. Now the thing is we have to find the derivative, and finally we plug the 0 and find the values, and then replug in this function. First let's find the derivatives. So we have to begin with f of 0. Let's go ahead and begin. So we have f of 0, right? So f of 0 is going to be equal to, let's say this is the function, right, f of x. So this is going to be, so before I write f of 0, let's write f of x. F of x is equal to e power 4x. That's our function provided in the question. Now we have to find the first derivative. So if you find the first derivative for this one, this is going to be, so this is a chain rule, right? We take outside derivative, it's going to be itself, but inside derivative is going to be 4x, derivative of 4x, that's going to be just 4. So we are going to have 4 times e power 4x. So that's going to be the first derivative. Now let's take the second derivative. Second derivative is going to be, again, this 4, again one more 4 comes here, so that's going to be 16 times e power 4x. And third derivative is going to be 16 times another 4, that's going to be 64 times e power 4x. So these are the derivatives. Now what we have to do is we have to plug 0 instead of these x values. And e power 0 is 1, right? If you plug 4 times 0, that's going to be 1. So f of 0 is going to be equal to 1. And again, now if you plug 0 for this one, e power 0 is 1, and we have 4 right here, that's going to be 4. So this is going to be f prime 0 is going to be 4. And the next one, f double prime 0 is going to be, if you plug 0 for this one, 4 times 0, that's going to be 0, e power 0 again 1, 1 times 16, that's going to be 16. And f triple prime 0, this is going to be 0, so 0, that's going to be 1. So this is going to be 64 times 1, that's going to be 64. Now let's go ahead and plug it in the original equation. This is our original function expansion. Now finally we have to plug this value in this one, right? First we are beginning with f of 0. So let's continue this one on top. So I'm writing the final answer. F of 0 is going to be 1, right? 1 plus f prime 0, we found out that's 4. So this is going to be 4 over 1 factorial. 1 factorial is just 1, right? So this is going to be just 1. So instead of writing 4 over 1x, we can write 4x, right? So we can directly write 4x plus the next value is f double prime 0. We found out that is 16. 16 over 2 factorial, that's going to be 2 times 1. 2 factorial expands like 2 times 1, that's going to be just 2. And if you divide this one by 2, that's going to be 8, right? So instead of writing 16 over 2, we can write 8 right here. So this is going to be 8. And then we have x square. And the next term is going to be f triple factorial. I mean f triple prime 0. That we found out that one, right? This is triple prime. Triple prime 0 is equal to 64. 64 over 3 factorial. So let's find this one outside and plug it. So 64 over 3 prime. 3 prime expand, 3 this is 3 factorial. 3 factorial expands like 3 times 2 times 1. So this is going to be 6. So 64 over 6 is same as 32 over 3. So we can plug 32 over 3 right here. 32 over 3 x cubed. And this is going to be the final answer. Now let's box this one. So finally we end up with this value. So this is going to be the third degree Maclaurin polynomial for this function. And that's how we do this kind of problems. I hope you guys find this video helpful. See you next time.